Hello class. Today we'll be trying to study about the graphical representation of motion. So first, when we'll talk about graphical representation of motion, here what we generally talking about is to understand when the object is moving in the uniform speed or non-uniform speed. So we know what is distance, we know what is time, and how we will represent an object in this part. So when a body moves with a uniform speed, it will travel equal distance in equal interval of time. Already in the previous classes, we had already learned about what actually is uniform motion. The uniform motion is when an object covers equal distance in equal interval of time. So here same thing, uniform speed is it will travel equal distance in equal interval of time. The slope of a distance time graph indicates speed. If the speed of the body is non-uniform, then the graph between distance traveled and time is curved line. So here let us come in this part. Look at here, there is a distance on the y-axis and here on the x-axis we have time. So when the distance and time are equal, means in equal intervals of time, if the equal distance is covered, then we called it as uniform speed. And look at in this part, here we have y-axis, this is your x-axis. In the x-axis, we will be representing it with time, and in the y-axis it is distance. So here the distance is not uniform in the equal interval of time. Because of that, this graph is not straight. That is why we tell this as non-uniform motion. So when the time and distance are equal, the line will be straight, and that is called uniform motion. And when there is a curved line, then we called it as a non-uniform motion. Okay, I guess you are clear with this. Now, when we talk about the speed time graph, so speed time graph when the initial speed of the body is not zero. Let us try to focus in this graph right here. If it was the initial speed 0, then that line has to be here in this 0. But it's not here at this point. Exactly, it is there from the B. So the graph shows the speed time graph of the body having an initial speed equal to OB. So here we will be taking OB as a initial speed. OB and accelerating from B to C. Then here, in order to calculate the value of acceleration, so look at here in this graph, we have to find this acceleration. So to find this acceleration, what we can do is, for such graph, we need to subtract the initial speed. We need to subtract the initial speed. OB is the initial speed and AC is our final speed. So we have a final speed AC and we will divide it with time. So in such cases, the distance traveled by the body in the given time is equal to area between the speed time graph and the time axis. So generally what we are talking out here is what happens or how we will calculate the acceleration of such graph where the initial velocity is or initial speed of the body is not 0. So look at here, if it was 0, it has to come from this point, but it is not. It comes from OB. So this OB is our initial and this AC is our final. So to understand this, how we will calculate it by doing this. When the speed here, that is area of trapezium OBCA. Let us look once again out here. Look at here, OBCA. Here OB is parallel to AC and this is a closed figure, four-sided closed figure where these two are parallel. That is why we called it as a trapezium. So to find the value out here, we need to find the area of this part. So this is actually trapezium. So we are going to calculate the area of trapezium. That is, area of trapezium equals to OBCA equals to half sum of two parallel sides into height. That is half OB plus AC into OA. So let us see once again out here. OB is parallel and AC is parallel. So OB plus AC and height is our OA. Height, we will take it as a perpendicular distance. So this is your perpendicular. That is why we are taking OA as a height. Okay. Then in the next topic, we'll be talking about the speed time graph when speed changes at a non-uniform rate. That previous one was for the uniform one. Now to make it understand with this, we have when the speed of the body changes in an irregular manner, means it doesn't cover equal distance in equal interval of time. At that time, what happens? The speed time graph of the body is curved line. Already we know that when the object is moving non-uniformly, it will form a curved line. So even now, the distance traveled by the body is given by area between the speed time curve and the time axis. So it looks like this. From here, we can calculate with the help of slope. Okay. If you have any doubts in this part, you can just tell me. Okay.